Good morning, Year 12. Today we're going to carry on having a look at algebraic fractions. We're not going to quite be dealing with partial fractions today, but we will need it for partial fractions next time. You've been dealing with algebraic fractions in GCSE and in A-level, but you've not really dealt with top-heavy algebraic fractions. So that's what we're going to be having a look at today, kind of converting improper or top-heavy algebraic fractions into mixed algebraic fractions. Okay, so first of all, we need to know when an algebraic fraction is classified as improper or top-heavy. So it's improper or top-heavy when the degree of the numerator is larger than the degree of the denominator. So what that means is this first one is improper because you've got x squareds on the top, which is a higher order or higher degree than the bottom, which only has x's. If we have a look over here at this one, again we've got x cubed here now on the top and only up to x squared on the bottom. So the degree of the top is larger than the degree of the bottom. So it's improper or top heavy. Sometimes when the degree is the same on the top and the bottom, that can still lead to an improper fraction. So if the degree is the same on numerator and denominator, then that's still an improper or top heavy fraction. So what we're going to learn to do today is divide our numerator and our denominator to get how many times it kind of goes in completely, and then your remainder. This bit at the front that hasn't got a fraction as part of it, it could just be a number, but it could have some x's, some x squareds or some x cubes in it as well. So we're going to start by thinking about how we would deal with it if it was numbers. So if we were trying to do 7 over 3, we would do 7 divided by 3. So 7 divided by 3 would give us 2 with 1 remainder. So we'd write the 2 here, and then we would write the 1 remainder on the top of the denominator that I had in the question. So we're going to use the same method for this next one. We're going to do the numerator divided by the denominator. We're going to see what we get from that. That will give us the ax add b, and then the remainder will give us this c part here. Okay, so we want to make x squared. So we're going to write x here. X times by x gives me x squared. X times by 2 gives me 2x. I need to then subtract that off. So I then do x squared take away x squared, which disappears, which is what I was hoping for. 5x take away 2x leaves me with 3x. So I now want to make 3x, so I'm going to add 3 on the end here. So 3 times by x gives me 3x. 3 times by 2 gives me 6. I then need to subtract that off. 3x take away 3x. Cancels each other out, and then minus 9 take away 6 gives me minus 15. So my remainder is minus 15. So my answer then is going to be x add 3, which is what I got when I did my division here at the top, and then I'm adding on my remainder, which is negative 15 over x add 2. So A was 1, B was 3, and C was minus 15. Please now have a go at this question here. Pause the video and then we'll go through the answers together in a second. Okay, so with my algebraic division then, I want to make 4x cubed. I've got a 2x here, so I need to do 2x squared. 2x squared times 2x is going to give me 4x cubed. 2x squared times by 1 plus 2x squared. Then subtract those two away from each other. First, the x cubed terms disappear. Minus 6 take away another 2 is minus 8x squared. I want to make minus 8x squared, so I'm going to need to subtract 4x. Minus 4x times 2x is minus 8x squared and then minus 4x. I'm subtracting that off. X squareds cancel each other out. 8x take off negative 4x, so that's like plus 4x, so that gives me 12x. I now want to make 12x, so I'm going to do add 6. 6 times 2x is 12x, 6 times 1 is 6. Subtract those away, x's cancel, minus 5, take away another 6, minus 11. So I got 2x squared minus 4x add 6, and my remainder was negative 11 over x add 1. So A was 2, B was minus 4, C was 6, and D was minus 11. Another example here for you to have a go at. Please pause the video and then come back to check your answer when you're finished. Here are your answers. Please pause this to work through your solution and make sure that you are happy that you got the same here. The last two questions in the exercise, question 9 and question 10, are worded slightly differently. There's an example of this in the textbook, which is example 12. You can work through this example. There's also another method that you can use for example 12, which you might prefer, so I'm going to work through that with you now. So this time, we haven't got a fraction as my question. We've just got a polynomial, so x cubed add x squared minus 7 can be written in this form. So what this is telling you is that we can partly factorise this, but then have a remainder on the end. So what we need to do for a question like this, or a method that we can use, is we can do the original question that we had divided by x minus 3. We do that division, and then d would be the remainder we get from the division, and the ax squared add bx add c would be the main part that we get from our division. So as with the previous example, I'm going to write 0x squared in here to help me with the layout of my division. So x squared times x, x cubed, x squared times minus 3. Subtract these away from each other, the x cubes cancel, and then x squared, take away negative 3x squared is 4x squared. So plus 4x squared minus 12x. Subtract those away. X squareds cancel, 0 take away negative 12 is 12x. So add 12. 12 times x is 12x. 12 times negative 3 is negative 36. Subtract those off. X's cancel, minus 7. Take away negative 36. So that's add on 36, which is going to leave me with 29. So my final answer then would be x squared add 4, x add 12, x minus 3, and then my remainder on the end, which was positive 29. Now please have a go at the exercise in the textbook.